We want to see if the integral from 0 to infinity of 1 over square root of x times e to the square root of x dx is convergent or divergent. We know that this is improper because at both upper and lower limits the integrand blows up. When x is equal to 0, the denominator is 0. When x is equal to infinity, you will have indeterminate form infinity times infinity, because e to the infinity is infinity, right? And that's not allowed. Well, infinity times infinity is not indeterminate, but 1 over infinity is indeterminate. I mean, it will blow up, right? It will be equal to 0. 1 over infinity is 0, right? So that's not allowed. So 1 over 0 is undefined and 1 over infinity is undefined, right? You have blow-ups in the integrand for these values. So we have to actually split this integral into two parts. From 0 to 1, that's convenient. 1 over square root of x, e to the square root of x dx, plus from 1 to infinity, right? We're basically creating a turning point between 0 and infinity, right? In order to create only one problematic limit in each of the integrals that we split into, right? So notice that when we do this, you will only have one problematic limit. In the second integral, it's going to be infinity. In the first integral, is going to be 0, right? But the second limit in both cases will be okay, because when x is equal to 1, this is defined, right? It's not the integrand does not blow up. So now, let me quickly calculate here what the antiderivative of this is going to be. We know that the antiderivative of this, using the u substitution, so when u is equal to square root of x, du is going to be what? 1 over 2 square root of x dx, right? And there's already square root of x in there, and the 2 will be there, so we have to eliminate that 2, right? So we have to have a 2, 1 over e to the u du, right? So basically it means that we're going to have this 2e to the negative u du. You would use a u substitution again. I would say v is equal to negative u, dv would be negative 1, right? So there will have to be a negative 2, right? So e to the negative u, what is the antiderivative of e to the negative u? It's going to be the same, right? Negative e to the negative u, right? So there's already negative there, so it's just this. E to the negative u plus a constant, which is equal to what? Negative 2 e to the, what's u? U is square root of x, right? Negative square root of x plus a constant. There we go. We just found. Okay, so now let's introduce the limit as r approaches 0 from the right, because the 0 is the problematic limit here, x value, and approaching from the right, from r to 1 over square root of x e to the x dx, plus the limit as r approaches 1 from the left now. I'm sorry, not 1, but infinity, right? Because infinity is the problematic limit. From 1 to r, right? 1 over square root of x e to the square root of x dx. Great. Okay, so now we can continue. We already found the antiderivative, right? It's this. We don't have to include the constant because we're dealing with improper integral, right? And virtually improper is still a definite integral, even though it's improper, right? So we don't need the constant. So it's going to be what? Negative 2. We're going to put negative 2 outside the limit as r approaches 0 from the right. Let's see. So that's going to be e to the negative square root of x, right? From r to 1. And then plus, but we have a negative 2 again, right? For the general antiderivative. So instead of plus, we're going to write a minus, right? Because plus minus is a net minus, right? Negative 2 limit as r approaches infinity now for the second improper integral. And that's going to be the same, right? The antiderivative is e to the negative square root of x from 1 to r, right? So now this is becoming easier. And remember, if one of these integrals is divergent, the other one you don't have to check. The original integral will diverge, right? So let's check that. So negative 2, the limit as r approaches 0 from the right, and that's going to be e to the negative square root of 1 is 1, right? So we can just write e to the negative 1 minus e to the negative of square root of r, right? Using the fundamental theorem of calculus, that's what I'm doing here, minus 2 the limit as r approaches infinity, e to the negative square root of r minus e to the negative, and again square root of 1 is 1, so we can just write 1. Okay, so what is that going to do? That is going to do, let's see, negative 2. Well, we don't have to write the limit now because we're going to evaluate it, right? So negative 2 e to the negative 1 minus, now if you plug in 0, e to the negative 0 is 1, right? So it's just minus 1 minus 2, and then e to the negative infinity is 0, right? Because we know that e to the negative x is going to be this function here. This is x, this is y. E to the negative x is this function, right? So if you take x to the negative infinity, right, this is negative x-axis. If you take x to the negative infinity, you know that e to the negative x will approach 0, right? So when r is equal to infinity, you will have e to the negative infinity, and you know that's going to be 0, because that's where you approach with the function e to the negative x as x gets negative. Oh, I'm sorry. Did I? This should have been e to the x. I got confused with many signs, right? This is e to the x, right? And e to the negative x is this one, but it still doesn't change, right? This is e to the negative x. If you substitute x with infinity, you will get e to the negative infinity, and you know that this will approach 0. If you set x is equal to negative infinity in the case of e to the x function, you will also approach 0, right? Because x will be taken infinitely small, right? It will be infinitely small. Infinitely negative, I should say, right? So it's going to be, if x is equal to negative infinity, you will approach 0 in both cases. If x is equal to infinity here, you will still have e to the negative infinity, you will approach 0, right? So in this case, we're probably using e to the negative x function here, right? We're using this function. And r is equal to infinity, right? Square root of infinity is still infinity. And e to the negative infinity is 0, right? So we have 0 minus e to the negative 1. That's it. Okay, so let's see. So now we're going to have what? We're going to have negative 2 e to the negative 1 plus 2, right? Minus, well, 0 doesn't matter, but minus 2 times negative 1 is plus, right? So plus e to the negative 1. So look what happens. These two guys are out because they're canceling each other out. One of them is negative 2, the other one's positive 2, right? The coefficient of e to the negative 1. So we have basically 2. So this is a convergent value. Okay, so we should say that the improper integral converges to 2. That's the value. Thank you so much for watching. See you in the next video.